Subcaliber rounds are one of the core types of tank ammunition. Today, we'll trace their evolution and see how they grew up into the main shells of modern MBTs. Different nomenclatures exist, but arguably the earliest rounds resembling subcaliber type were the APCR and HVAP. These munitions carry their outer shells with them all the way to the target. On impact, they deform, releasing the tungsten core, which then penetrates the armor. The main drawback is obvious. The outer shell creates extra drag and slows the round down. Toward the end of World War II, British engineers figured out how to fix that. They designed a sabot that separates right after leaving the barrel. Its petals open due to centrifugal force and airflow. Discarding sabot subcaliber rounds became the post-war standard. However, even during the late war years, German engineers were working on a fundamentally new concept: the fin-stabilized subcaliber penetrator. It also used a discarding sabot, but the core itself was long and slender. These rounds weren't suitable for conventional rifled guns because excessive spin would destabilize them in flight. The simplest solution was the move to smoothbore guns. Originally, the Germans envisioned fin-stabilized subcaliber rounds for anti-aircraft guns against bombers, but thin air at high altitude hurt their accuracy. Later, attempts were made to adapt them for anti-tank guns and ultra-long-range artillery. Germany didn't manage to bring these projects to completion, and after the war, the work continued in the USSR. The first mass-produced tank to fire APFSDS from a smoothbore gun was the T-62, adopted in 1961. By the mid-1970s, the new subcaliber rounds also entered the ammunition load of the T-55, despite its rifled gun. In the United States, experiments with smoothbores were already underway in the 1950s. The T-95 medium tank was supposed to receive such armament, but never progressed beyond prototype stage. By the late 1970s, Western designers also developed fin-stabilized rounds for rifled guns by creating a special sabot. The outer part that contacts the barrel spins, while the inner section and the penetrator remain almost non-rotating. The earliest APFSDS penetrators were made of steel, but very quickly they moved to harder materials, tungsten alloys, and even depleted uranium. The choice of DU has little to do with radiation. The key point is that at similar density, uranium is far less scarce in wartime than tungsten. Still, the main development path for APFSDS has been increasing penetrator mass and length to diameter ratio, often called LD. Early darts had an LD of roughly 10 or 15 to 1, while late-generation rounds reached 25 or 30 to 1. But you can't shrink the diameter and stretch the length forever. Picture it. On the most modern rounds, the penetrator is about as thick as a human finger, while total length pushes toward a meter. Beyond that, you start running into strength limits for tension and compression. And that's only half the problem. The latest rounds also run headfirst into the physical limits of ammo racks and autoloaders. Penetrators are being seeded so deeply into the casing that they're almost touching the base. And even then, the overall length is still awkward in cramped fighting compartments. The next step in improving armor penetration has stretched for decades, from the 1980s to today. The most straightforward answer is bigger caliber. Different countries are testing 130mm, 140mm, and even 152mm tank guns. But fitting these weapons creates a long list of issues. Barrel life drops, balance and weight distribution become harder to manage, the carried ammo load shrinks dramatically, and an autoloader becomes essentially mandatory because the rounds get too heavy for a human loader. On top of that, changing caliber instantly devalues thousands of rounds stockpiled since the last century. So what do you think tank guns and tank shells will look like in the future? Tell us in the comments.